Hello everyone, I am Zahin Tazwar and currently I am an undergrad student of North-South University majoring in Electrical and Electronics Engineering. Today I would like to share my junior design project with you all. Junior design project is basically a hardware design project and one has the opportunity to choose the project medium. They can either use a Raspberry Pi or an Arduino or any other sophisticated microprocessor or microcontroller to build a high-end project. Our junior project was an industrial sensor enhanced with a GSM module. The sensor basically focuses on the industrial hazards or accidents such as fire breakdown, gas leakage, or earthquake or vibration in any industry or factory, and will notify the rescue team or the fire brigades for help through SMS or phone call. So without any further delay, let's implement the circuit. For the ease of your understanding, I will be explaining all the wirings and connections slowly and clearly so that everyone watching this video can make their own GSM sensor. So I am using Arduino Uno board for my project. I could have used Arduino Nano, but as I am working with 4 sensors, I had to come up with the Arduino Uno series. As you can see, the Arduino Uno has essentially 14 digital pins and 6 analog pins. First, let's make a common ground. This is a useful trick when it comes to build a big project on a breadboard. I am placing the Arduino board just at the center of the breadboard to reduce wiring and connection complications. Let's start with the sensors now. Our first sensor is the vibration sensor. As you can see, the vibration sensor has 3 pins. The leftmost pin is the digital output, the middle one is the ground, and the rightmost is the VCC. We will place this in the breadboard in such a fashion so that it gets the proper biasing. It also receives the appropriate ground, and it also has the correct digital output pin which is connected to the Arduino. The vibration sensor is connected to the digital pin number 8 of the Arduino. Then the DHT temperature sensor is connected to the digital pin 2 of the Arduino. Similarly, the flame sensor is connected to pin 10 of the Arduino, and the gas sensor is connected to pin 12 respectively. As you can see, I am connecting the Arduino pin to the breadboard, and from that same node I am providing the digital output connections for the sensors. In this way, we can minimize the use of wires and can build the circuit into a neat and tidy one. Next comes our output components, which are basically the LEDs and a buzzer. The yellow LED is connected to pin 9 of the Arduino, and the LED is placed in such a way so that the negative trail is connected to the ground and the positive leg is connected in series with the resistor. Similarly, the red LED is connected to pin 11, green LED at pin 4, and white LED at pin 13, and the buzzer is connected at the pin 3 of the Arduino. The LCD module is connected with I2C module. I2C module connections are quite simple. The ground, it is connected to the common ground of the breadboard, and then the SCL is connected to A5 of the Arduino, and then the SDA is connected to the A4 of the Arduino, and these are connected in the analog output. Now we have our LCD connected, but remember to short this connection, the LED and the power connection, before we are working with LCD module. And this is the potentiometer which we will be using to adjust the contrast and the backlights of the LCD. Then we have the GSM module. I have connected the RX pin of GSM to pin number 7 of the Arduino, and the TX pin is connected to the pin 6 of the Arduino. And then we have a common ground which is connected to the common ground of the breadboard. And remember to use an external power supply for the GSM. Here I am using an external power supply, a 12 volt external power supply to power up my GSM, which is much more easier rather than just biasing the GSM with the Arduino. Then finally, this orange wiring which you can see is the 5 volt from the Arduino, which we will be using for biasing the entire circuit, and this is the common ground from the Arduino, which is used for creating a common ground connection for all the components we are using. That's all about the connections and wiring, and in the next video I will try to explain you how the coding for this Arduino Uno was implemented. Thank you everyone.